Okay, so what do I forecast? Definitely sales demand forecasting in supply chain, in retail. I'm doing a lot of that. Forecasting in energy, there are many, many use cases in energy, like demand, prices, renewable energy production, building efficiency. I've worked on predictive maintenance, like road, railways, also mining is a big sector here in Australia, and also other things. But I think maybe just as important as what I forecast is what people think I forecast, but I don't. So one thing is the weather. There's lots of domain knowledge and specialized models. So we leave it to the meteorologists and really specialized people. But we often use weather forecasts as inputs to our models. And then another thing that I don't forecast is the stock market. So you see, for stock market forecasting, there are these obvious pros why you should do it. There's lots of freely available high frequency data that you can just download off the internet. And you have this very clear motivation and use case, which is making money. But there are lots of cons, and the biggest problem is that it just doesn't work very well. So because the share price is not a function of its own past, but of its anticipated future, you have very low signal to noise ratio, and then markets tend to be close to efficient. And forecasting in efficient markets is not possible beyond just the naive forecast, which is you just take the last known observation as your forecast. So as a consequence, in finance, it's usually all about predicting risk, not returns, like predicting tails of the distribution. And in fact, Robert Engle got the Nobel Prize in Economics in 2003 for methods of analyzing economic time series with time varying volatility. These are known as arch models, because the big thing back then was that volatility can actually be forecast, because volatility tends to cluster together. So if you have like a lot of volatility on one day, you are more likely to also see high volatility the next day. So you know there will be big changes, or that big changes are likely, but you don't know in which direction. You don't know if they are going to be huge jumps, higher or lower. Yeah. So in the end, predicting stock market returns from just a couple of lagged values won't work, no matter what method you are using. And all of this is true in a similar way also for exchange rates and other asset classes. So what can we forecast? Well, in forecasting, the fundamental assumption is that the future depends on the past. So we need past data and experience to extrapolate. But predictability varies widely. So just to give you some more examples, next Monday is time of sunset. That's very predictable, because we understand the physics behind it, and we can predict it very accurately to the minute. And not only next Monday, you can say this arbitrary day in 500 years from now, we can already predict the sunset and sunrise there very accurately. TV schedule in 2 weeks' time. So that's quite accurate, because the people who like the publishing companies, the broadcasters, they publish this TV schedule and they usually stick to it. And so you can know what will be the TV schedule in 2 weeks' time. But then, of course, there can be changes, and they are much more difficult to foresee. What about something like next Saturday's lottery numbers? That's obviously impossible to forecast in the usual case. And you see, I can tell you, but I give you 20 years of lottery numbers, huge data set, and why don't you run some machine learning on it and use that to forecast next week's lottery numbers? And well, it's not going to work, because that's obviously a statistically independent event. So the past data will have no predictive value for the future. And these financial variables like exchange rates, stock prices, and so on, I mean, they're not quite like the lottery numbers. They have some signal in there that you can use, but they're quite high up there with the lottery numbers, I would say, right? So it's, even if you have a lot of data, this data is not necessarily helping you to forecast. So what are important factors for predictability? Well, how well do we understand the underlying phenomena? How much data do we have? Will the forecast affect the future? So this last one, think about, you are a big governmental agency that then forecasts, I don't know, unemployment rate. And then obviously people would say, oh, we need to do something about it. And then the forecast actually doesn't come true. So actually often that's used, right? So you predict some sort of horror scenario, but obviously you don't want to be right about your forecast. You want people to then work so that this doesn't happen. But what we talk about in this training course is forecasting with mathematical models, where our goal is to model adequately the repetitive patterns that we have in the data. And we do not want to distract us by noise and unique unforeseeable events. So our main goal is to separate the time series into a part with predictive value and a part of noise. Yeah, and now keep in mind, forecasts are always wrong. So you should use prediction intervals to quantify uncertainty. So you see, the goal is never to say, okay, I'm going to predict tomorrow's sales or next week's sales, and I'm going to exactly know the number. It's always about kind of, well, with 80% the sales are going, with 80% probability sales are going to be in this interval between this value and this value. Yeah, another thing that I often think is important is, if you don't have to forecast, then don't forecast. So what do I mean with that? Forecasting usually is done for decision making. So ask yourself, can this decision be made without a forecast? Focus on resilience of the decision making. It's always a really bad idea if you say something like, if I had a perfect forecast, I could make an optimal decision. Yes, but maybe it's a very uncertain thing that you try to forecast, and your forecast is just not going to be any good. And maybe you can make this decision in a better way so that it doesn't rely so much on a forecast. And then last point, in my experience, it's really forecasting will give you the biggest wins in situation where you are already using a bad ad hoc forecast in your decision making. And maybe you don't even realize that what you're doing is doing a forecast, right? So let's say you are tasked with predicting, so you know your company needs to order plastic Christmas trees for next Christmas, and the question is, how many should we order? And you say, well, how many did we order last year? Okay, well, more or less this is going to be it. So now you've done a naive forecast, right? You've used last year's number as a prediction for this year, so that's a forecast, even if it maybe doesn't really look like a forecast to you. Okay, that concludes the introduction section. The next part is going to be traditional statistical univariate forecasting techniques. Thanks.